I'd like to announce that we are now starting today's seminar titled Ocean Science and Policy Nexus, UNOC 3 and Beyond. Special seminar with Dr. Peter B. Menocal, President and Director of the WHOI Oceanographic Institution. Thank you very much for attending this seminar. The seminar is organized by the Ocean Research Institute of the Sasakawa Peace Foundation, OPRI-SPF in short. I am Mai Fuji from OPRI. I will be a general MC for today's seminar. To begin the seminar, let me invite Dr. Mitsutaku Makino, President of OPRI and Professor at the Atmosphere and Ocean Research Institute, AORI, the University of Tokyo, for his opening remarks. Dr. Makino, the floor is yours.
Distinguished guests, friends, colleagues, and Peterson, good afternoon. Thank you very much for participating in today's event, special session entitled Ocean Science and Policy Nexus, UNOC 3 and Beyond. My name is Makino, the President of OPRI and Professor of University Tokyo. This year, 2025, is a very special one for the ocean, as the leaders around the world will renew policies and actions for a sustainable ocean at the forthcoming third UN Ocean Conference in Nice, France, this June. We held the World Ocean Summit last month in Tokyo, and later this month, the Our Ocean Conference will take place in Busan, Korea. These events highlight the urgent need for globally concerted actions to promote ocean sustainability. At the same time, we must strengthen global partnership to tackle climate change, which continues to negatively impact the marine ecosystem. We must reinvigorate our global cooperation for the sustainability of our global commons, the ocean and the atmosphere. In this context, it is our great pleasure today to welcome Dr. Peter B. Menocal, President and Director of the WHOI Oceanographic Institution, as the keynote speaker of today's special seminar. The WHOI Oceanographic Institution, WHOI, is a world-leading ocean science institute, as all of us know very well. And we, OPRI of Sasakawa Peace Foundation, have collaborated with WHOI for years, including our partnerships for the Ocean Pavilion at UN Climate Change Conference of the Parties. Also, last year, one of our OPRI researchers, Dr. Tanaka, visited WHOI for 3 months and had a very important experiences and learning there. We are also joined today by leading experts from Japan, the ocean science community, Professor Saito of University Tokyo, Dr. Hasegawa of Japan Fisheries Research and Education Agency, and Dr. Yamakita of Japan Agency for Marine Earth Science and Technology. Today's topic is the science policy nexus. This is a key theme of the upcoming Nice Ocean Conference, and it is also a priority focus of the UN Ocean Decade, which is now at the midpoint, the turning point of just 5 years past towards 2030. Advancing ocean science requires a long-term, intergenerational, and global coalition, supported by a wide range of stakeholders, society, as well as policymakers. Today, I am very confident that this special seminar will provide valuable foundation and future perspectives and help strengthen the science policy society interface. Also, I hope that this special seminar will be the beginning of further collaboration among ocean policy research institutes in United States, Japan, and around the world. Thank you very much.
Thank you, Dr. Makino, for your message. As he mentioned, I believe today's seminar will give us a lot of inspiration towards UN Ocean Conference, especially about the interface between science, policy, and society. I now have a pleasure to introduce Dr. Peter B. Menocal, President and Director of the WHOI Oceanographic Institution, WHOI in short. Dr. Menocal is the 11th President and Director of WHOI Oceanographic Institution. Prior to assuming leadership of WHOI, he served in a number of distinguished positions, including Columbia University's Dean of Science for the Faculty of Arts and Sciences. As a marine scientist, he is an outstanding expert of geology and paleoclimatology, and also founded Columbia's Center for Climate and Life, a climate solutions research accelerator. So we are so excited to listen to your speech. Dr. Menocal, the floor is yours.
President Makino, I thank you so much for such a generous invitation for me to come join you here in Japan today. It just gives me great joy to be in your beautiful country. You're just so welcoming and kind. And we share a love for the ocean. And it's really my distinct honor to be in this incredibly important institution, both with the Sasakawa Peace Foundation and also with OPRI. And most recently, I was able to meet with Mr. Uno, who's head of the Nippon Foundation, to discuss some of the matters that we'll be talking about today. Before I begin, I have many people to thank, one of whom I think probably everyone in the room here knows is Dr. Kilaparti Ramakrishna, or Rama, known for short. He's someone who has brought us together. I'd like to thank him for the opportunity to be here today, but really to President Makino for really the kind invitation, and Director Watanabe, congratulations on that recent appointment. Masa has been just a remarkable host for me over the past many weeks, organizing an ever-changing schedule. And Kotaro, you can tell Kotaro and I are friends and colleagues because we're wearing the same tie. This is the WHOI tie. It's been a pleasure to have you at the Oceanographic. I'll start really at the beginning of why I'm here in Japan, why I'm here also to be in Osaka tonight. And it's really to focus on the ocean, but really to build partnership and friendship between Japan and the United States, both as nations but also as leaders of oceanographic research. The long and storied history of Japan's leadership in ocean science really couples very well with our very long story at the Woods Hole Oceanographic. And what I'd like to do today is to just give you a little bit of a snapshot of what it is like at the Woods Hole Oceanographic Institution. What is distinctive about us is that we are the world's largest private institution dedicated solely to understanding ocean science and technology and advancing the next generation in an education program with MIT. That focus and that independence is the reason why I left a 33-year-long career at Columbia University. Imagine if someone gave you the largest and most capable oceanographic team of these independent scientists and said, go after some of the world's biggest challenges. It's just a tremendously exciting time. And again, I'm going to hit on a major point, which is the work I'll be describing today is bigger than any one institution. And this is a big part of my reason for being with you today. So the Woods Hole Oceanographic Institution, or WHOI, or WHOI, as it is well known and loved by everyone who knows us. It happens to be a terrible swear word in Russian and means nonsense in Southern American dialect. So it's a very unfortunate nickname, but we say it proudly. We were founded nearly a century ago based on a $2 million, actually a $2.5 million grant from the Rockefeller Foundation. They built our first building, and we are now up to about 77 buildings. For about 55 years, we've had a joint program with the Massachusetts Institute of Technology, and we have about 150 students at any one time. It's about 1,200 employees. It's larger than most people think. 2 campuses, 2 large global class ships, about a $350 million operating budget, of which 80% are individual grants that are awarded to our scientists. For those of you who are reading the news, actually even today, you can see why I may be a little distracted in my talk because that dependence on federal funding has been a badge of pride for the Woods Hole Oceanographic, and it continues to be. What I'm going to be talking about is really the people that I represent. This is not about me today. This is about the amazing men and women who are the scientists and the engineers and the technicians who work tirelessly to understand our ocean world. It's one thing to show a ship on the ocean. All of us have seen this ship in the rough seas making its way through. Excuse me. But being an oceanographer is one of the hardest professions to choose because not only are the problems difficult, but they're intrinsically multidisciplinary. And you're working in an environment that's unforgiving, and in some cases at pressures that are crushing in an ocean that wants to kill you. And so this commitment to science and to understanding comes with a very special degree of commitment. Sometimes to convey to an open audience, Japan is a seafaring nation. You have a long connection with the ocean. But sometimes when I show what it's actually like to be on the research ship, either in transit, going to someplace to do the science, or staying put and working at a particular station, people are surprised at just how rough and unforgiving and dangerous the ocean conditions can be. The intent of these images are sometimes to convey to people just how difficult it is to do the very basic science of observing in the ocean. And this is actually going to be a real focus of my presentation today. This is something that your scientists do. This is what scientists in America do, scientists in China, scientists all around the world who work on the ocean. This is our office. The main aim of the Woods Hole Oceanographic is really to advance our basic and applied understanding of fundamental ocean problems or questions, and really trying to use that knowledge to then explore deeper and more pressing questions that today are becoming increasingly urgent. We're committed to advancing the frontiers of knowledge, very much like the fine institutions here in Japan. An additional focus that we've always had, but one of the ones that really drew me to take on this role to head the Woods Hole Oceanographic, is the ever-increasing importance and the urgency of our work to address the challenges that await us today and that are rapidly accelerating for the remainder of our lives and for the next generation. The ocean is the single biggest gear in the climate machine of the planet, and our understanding about it is vanishingly small. Sometimes in a role as head of an institution, someone will ask you 1 or 2 years into the job, and I'm sure this has happened to you, President, what is the thing that surprised you the most, now that you've been in the position for a couple of years? For me, what surprised me the most about the Woods Hole Oceanographic is, despite its size, it's a very nimble place. We can go after problems really quickly, and they can be very big problems that are actually at a very high price point. And that's because our scientists are able to take on risks and apply new technologies to go after problems that are difficult for some other organizations to pursue. And the way the place feels when you're there, and I think Kotaro can echo this, is that it's a very intrinsically collaborative place. It is the absence of hierarchy. Other than me, everyone is just at exactly the right same level. And I'm only different because I'm here speaking on behalf of them. It's a very egalitarian and teamwork kind of oriented location. Another defining characteristic of the Woods Hole Oceanographic is our, I would say, unparalleled access to the sea, not so much because of our global class research vessels. Of course, Japan and JAMSTEC have 3 times as many ships as we have. But it's really how we extend our understanding of the ocean with both sensing networks and autonomous vehicles coupled to developing technologies that give us new ways of looking at the ocean. Some of you may know our submersible that also goes to 6,500 meters. Was just recently refit. I actually had a chance to dive on Alvin off of California last summer. And I don't know, just a show of hands, how many people have dived in a submarine before? 2, yeah, so a handful of us here have been on a deep sea submarine. One of the things that's hard to describe to someone who's never done it before is that feeling of going down from the sunlit portion of the ocean, which all of us know, to a little bit deeper when it becomes an aqua that all of us think we know. And then you go through the spectrum of colors that don't exist in the palette of the land. And the depth and the richness of color are sort of undefinable. And that is something that really stuck with me from this experience. In the process of exploring, actually Alvin was used to discover the location of the wreck of the Titanic. That's an old story for us, and of course you probably have seen the movie. That's all images that we took at the end of that movie. That's all our footage. We also discovered hydrothermal vents, which are believed to be one of 2 sources of the origin of life on this planet. This kind of fundamental discovery comes from people who are willing to take risks. One of the things we've done historically is to be the first on the scene for this disaster in the Gulf of Mexico for the Deepwater Horizon. We had a chance to actually dive on the site and observe the flow itself and to sample the chemistry of the oil to define where it was coming from and how it was being impacted and how it was degrading in the natural environment. But those are sort of early stories of WHOI, and really WHOI today is this gathering of scientists that are looking at the role of the ocean and climate, this ocean climate nexus that we've been talking about, sea level rise and coastal assets, future energies such as offshore wind, the future of food, particularly fisheries and the impact on climate and other factors on overfishing, for example, marine mammals, coral health, oceans and human health, harmful algal blooms, technology and future ocean sensing, marine microplastics. We're leading a new initiative, a big new initiative on that right now. And there's a commitment to understanding both the deep ocean, the polar ocean, and the twilight zone as these last frontiers on our own planet of discovery. On the climate solutions work, I won't spend that much time on this other than to say we've been thinking about this as it started with a consortium of individual scientists that were all working on their own, and we've made it so that there's a climate solutions hub whereby scientists with expertise that support each other toward a larger research question. We have ways to invest in them for them to pursue some of the high risk but potentially high impact research that leads to solutions. Same thing for marine plastics. We've developed a plastic that degrades with ultraviolet exposure to ultraviolet radiation from the sun. On coral conservation, there's a whole group of scientists across all of our 5 departments that are committed to both coral conservation and meeting the fate of the increasingly vanishing coral world on the planet. Where people get very excited when they come to visit us is when they come to see our robot labs. Of those 77 buildings, I'd say almost half of them are places where we're either building sensors or robots or everything in between. And basically the idea is that in order to measure things in the ocean, using the tried and true way of taking a ship and a bunch of people to a location is great, but it doesn't give you the time and the time on station and the spatial distribution that you need that you can get from using autonomy. There's a program called the Ocean Observatories Initiative that we run. It's actually a federally funded program at about $50 million a year to observe the ocean at scale. So these are networks of sensors that are designed to understand how the ocean environment is changing in key hotspot regions around the world. To explore, for example, the impact of ocean warming on offshore fishing. And in fact, I think my next speaker, or the next speaker, is going to be speaking on that in some detail. You're probably all familiar with the Argo program. This is a series of about 4,000 floats around the world's oceans. A quarter of them are developed and launched by our team. And this is one of the best examples of international cooperation. It's the single largest, most successful joint ocean science venture to date. Most of these floats are only measuring temperature and salinity, what we call state variables. And this collection of sensors is what tells us that the ocean has absorbed about 93% of the excess heating from the buildup of greenhouse gases in the atmosphere. But when we ask the question about, well, how is the ocean as a living, breathing fluid, this sort of multimedia soup that is our ocean planet, we're basically flying blind because we don't have nearly this many sensors that tell us anything about the carbon system in the ocean. The ocean has a carbon reservoir that's 50 times that of the atmosphere. And so the carbon storage potential of the ocean is something that's well known to oceanographers. And so there's a number of organizations and institutions around the world that are exploring this question of, well, can the ocean take up additional carbon from the atmosphere to reverse the impacts of global warming? And indeed, that's already happening today. The ocean takes up about a quarter of our emissions every year. But just as a thought experiment, if you could capture the entire excess carbon dioxide that's in the atmosphere today and mix it into the ocean like a martini, top to bottom, throughout the world ocean, it's about a 1% addition to the ocean's carbon content. That is, it's a drop in the ocean. And so a number of organizations, many of them private, many of them not open to public scrutiny, are looking into exploiting this way in which the ocean can take up carbon. And so we took a position on this at the Woods Hole Oceanographic. We said that basic science has to lead the knowledge frontier of this problem, because if we don't, we lose the opportunity to inform the unintended consequences of doing any intervention at scale. So this idea of, let's say, amplifying the ocean's carbon potential to use photosynthesis to sink more marine carbon down to the deep ocean, we know that that's something that the ocean has done in the geologic past. And the ocean has taken up 100 ppm equivalent of carbon dioxide between ice ages and warm periods. What we don't know is that if we tried to do that at any kind of scale, is this something that we would like that is works without negative consequences? We also are looking into abiotic solutions, that is, ways to use changes in ocean chemistry based on natural processes that can also take up carbon at scale. We have research programs on this at the Oceanographic as well. I think a large part of the reason why I'm in Japan here with you today is because of Japan's partnership at the very early beginnings of something called the Ocean Pavilion. At the COP meetings every year that the UN hosts in typically inaccessible parts of the world, there are pavilions. There's a Japan pavilion, there's a United States pavilion, there's a Russian pavilion. There had never been an ocean pavilion, even though it's 70% of the planet. And so the head, or my counterpart at the Scripps Institution of Oceanography, Margaret Leinen, and I said we should get our partners together to develop a pavilion for the next COP. And this was for the COP27 in Egypt. And OPRI was one of our very first partners. Japan was one of the very first partners in developing an ocean pavilion. And over the last 3 years, we've been doing this together in building not only the pavilion and filling it with 2 weeks of content, bringing thousands of people, but one of the things we discovered is that having an ocean pavilion served just like the ocean serves humanity today. It's a natural magnet that brings people together. It's something that we all share. And so people would come to the pavilion saying, why is there an ocean pavilion? And what a great question to have to answer. And so it turned into this way to basically redefine the ocean's role in these climate negotiations, because the ocean's largely been absent from those discussions. And this is really what I wanted to speak on today, which is as we look to the UNOC, the United Nations Ocean Conference in Nice, my team will be there. I think a number of Japanese will be there as well. But it's going to be this global gathering to understand how we can accelerate the science and the solutions, the technology, and especially the social science that's needed to deliver scalable ocean-based climate solutions. Just so we know here, this is the OPRI team up at the top with big smiles. It was a great teamwork to be together, and Kotaro was, I think, fortunate enough to be able to spend some time with us at the Oceanographic. There's my colleague Rama and the figure below, and me looking up at him waiting for a cue, I think. But what I want to share with you today is a vision that we have that we're actually working on right now, which is, remember when we were looking at that suite of Argo floats for the ocean? Well, those were informing temperature and salinity and pressure for the most part, for the upper 2 kilometers of the ocean. But we're basically flying blind with respect to the carbon system in the ocean, particularly at a global scale. So we're envisioning this undersea network, this Internet of the Ocean, that consists of sensors for carbon and nutrients in the ocean system that are clustered in regions that are either hotspots or places that are changing rapidly, or places that can be used to explore these marine carbon dioxide removal approaches to understand their effectiveness, the durability of carbon storage, the safety of the approach, and whether it's really a viable solution. So it's not just the Woods Hole Oceanographic, but it's a number of institutions around the country in the US, but also around the world. But how do you scale? This work began with a $25 million gift from our board chair, who was so compelled by this problem, he said, you need to get working on this now. And he's right. And together with federal funding, we've raised about $50 million toward this ambition. But this is easily a $1 billion problem. That's going to take all of us. So how do you get to scale? Well, the United Nations has the UN carbon trading mechanism, for which the ocean has a very nascent policy. And then there's also the Global Greenhouse Watch program, which actually has funding available for scalable solutions, but mainly terrestrial. To take advantage of the known scaling that's available in the ocean, we're exploring this United Nations Center on Ocean Climate Solutions, with the idea of creating a global hub for stakeholders just like us in the room to work together to accelerate this kind of work. And I wanted to just return to a comment that was raised in a group when I was meeting with the OPRI group yesterday about what do we think is needed to get to scale. And we've learned a little something about this in the process of these marine carbon dioxide removal challenges, which is that, of course, you need fundamental ocean science, lots of it by all of us, and that's something that we're doing. We also need ocean observing and monitoring at scale. We don't have that now, but we know how to do it. And in fact, one of my conversations with Mr. Uno of the Nippon Foundation was, how can we envision building something like this together? Because it's going to take all of us to step up to a really big challenge like this. And lastly, and in blue, a different color, is what I think is actually the hardest part, which is how do you get people, how do you address the bigger question, the social license for scalable solutions, bringing international partners together, developing ocean policy, involving stakeholders. That, probably to no one's surprise in this room, has been one of the hardest challenges of this whole journey, which is that we learn so much from the scientific community, and we know what to do, but then how do we turn that to action? And that's, again, a big reason why I'm here with you today. So I'm going to close on that, but really I want to thank you for your tremendous generosity and hospitality in welcoming to your country, but also to this amazing institution. And it's just it's a real delight to be back in Japan, and thank you so much for the kind invitation.
Thank you so much, Dr. Menocal, for such a comprehensive and insightful speech. So I am sure that you have a number of questions and comments. However, please allow us move on to the next panel discussions and have Q&A sessions all together thereafter. So now I invite the panelists to come up to the stage. So from now, I will hand over the floor to Mr. Masanori Kobayashi, Senior Research Fellow of the Sasakawa Foundation, to moderate the panel discussions.
Thank you. Good afternoon. I'm just introduced Masanori Kobayashi. I'm very pleased that Peter is here with us, giving us a very insightful and inspirational presentations. As he mentioned that we've been collaborating with USFO over the last number of years, particularly at the Ocean Pavilion at the occasion of the UN Framework Convention on Climate Change Conference of the Parties. And we are very delighted to have him and continue a conversation, particularly this ocean science and policy nexus, and a little more emphasis on this climate change and oceans from a holistic viewpoint. Just to introduce what kind of work we do, just briefly, it's a little bit of small proportions of the work, but I just wanted to mention a couple of things. I have prepared a short slide just to tell that we've been working also on the sustainable blue economies and the impact of climate change, including seawater warming on the marine environment and the fisheries. And we try to address these ocean issues from a more holistic viewpoint, including like climate change, biodiversities, overfishing, and also marine pollutions. And just an example that I think many of you already know, that seawater temperature around Japan has been rising quite tremendously. And it's not really homogeneous like average temperature rise, but in east coast of Japan, I think Dr. Hasegawa probably elaborate more later on. But there are different ocean divisions of the areas where the higher seawater temperature rise is exhibited. And as you can imagine, that has been causing a multiple impact on the marine environment and fishery sectors. This is another map shown by the IPCC, Intergovernmental Panel on Climate Change, and that shows the different impact on the fish catch projections around the world. And as I circled in the red color, the Southeast Asian regions shows largest fish catch reduction projections for the next 20, 30 years. It is mainly because the fish swim away from the equatorial zones to either the northern pole or southern pole or the eastern part. And many countries, including the Pacific Island countries, have a higher concern over the possible reductions in the future fish catch. This is something I just try to illustrate the story that I have been hearing from the local fishermen in Hayama, Kamakura, and Azushi, the neighborhood of my communities. And the people also tell us that as seawater warms up, like a seagrass in the shallow areas disappears. And seagrass disappears in the shallow areas, but they can still find the seagrass in the little deeper areas. And what happens is that, for instance, when we speak to the female diving fishers in like Shima or the Mie prefectures, they tell that the women, they can hold a breath maybe 5 meters, but not 10 meters. And male fishers, they can dive deeper. So we see also the difference in terms of the abalone corrections made by the female fishers and the male fishers. So there can be a possible implications, not only like a spatial distribution of this impact, but also like a vertical impact of the seawater warming on like, the availability of fish stock and also the fish collections of the fishermen at a different level of the water column. And when it comes to the fish, again, like shallow areas, they say that they cannot find fish, and they have to go a little deeper. And when they do trawling fishings, like shallow areas, they don't catch fish. And that may be the reason why they are not getting because fish is swimming a little deeper in that vertical areas. Again, these elements probably have to be verified by more scientific monitoring, but from my research experience, has more to do with like interviewing and questionnaire surveys with the local fishermen. Local fishermen tell us stories that I just illustrated in this diagram. And of course, coping or countermeasures, they probably have to dive deeper or fish in the deeper areas, or they have to find a new market of the new species that they haven't really got the fish before, but they are now seeing more tropical or semi-tropical fish in that area that they don't know where to sell. So that kind of marketing issues has to be also made adjusted in order to respond to the changes in the marine and the fishery areas. So as Professor Makino mentioned, that we have 3 distinguished speakers plus another colleague of mine called Taro, who will give us a little more insight from their research work to supplement Peter's keynote lectures. And based on that, we'd like to entertain questions and comments from you to have a panel discussions. So first, I have a pleasure to introduce Professor Hiroaki Saito, the Professor Atmosphere and Ocean Research Institute of University of Tokyo. And he's a very active member of the UN Decade of Ocean Science for Sustainable Development and a member of the advisory board and this UN Ocean Decade. So may I invite Professor Saito to take a floor.
Thank you very much, Kobayashi-san. And I'm very happy to be here to talk something about science policy nexus and also discuss with panelists. And as Peter already mentioned, and Kobayashi also mentioned, our ocean is changing. And because of human population, increase of human population and demand, and human being is so powerful to change everything. And we see various types of the degradation of ecosystem and the loss of biological diversity. Under serious condition, you may know that the United Nations proclaimed in 2017 the UN Ocean Decade for Sustainable Development, 2021 to 2030. The UN Ocean Decade is the best opportunity to prepare scientific knowledge for decision making to realize the ocean we want. As a marine scientist, I'm so excited to the decade and having a chance to contribute to the society of my generation and my next generations. UN Ocean Decade is could you change the slide, please? Oh yeah, okay. Okay, thank you very much. It's quite well recognized by community of scientists. Now we have 59 global projects and more than 1,000 regional, national activity and project. And more than almost 10,000 scientists, stakeholders under the network of the Ocean Decade Network. It's a really global activities indeed by ocean stakeholders, including scientists. UN Ocean Conference next in Nice is a quite important event to share knowledge and ideas and may prepare various opportunity to know each other of the network people interested in the changing ocean. And develop collaboration plan or finding best talent to reach the goal of each activity or UN Ocean Decade. I'm serving as an advisory board member of the UN Ocean Decade, and one of main issue of discussion is how to develop best policy for sustainable ocean, sustainable community, and human well-being. I totally agree that we scientists need to think seriously about how to prepare scientific knowledge to non-scientists, means the students, stakeholders of various private sectors, and decision makers, of course. We scientists need to develop skills to communication with non-scientists. It's challenging for me, but exciting experience. UNOC 3, next in Nice, I will attend, is also the best arena for the purpose, I believe in. At the same time, I'm a little bit worried or nervous about how well we know about scientific knowledge and products from UN Ocean Decade activities. More than 1,000 activities, more than 10,000 network partner contribute. Usually one big project have 100 scientists or 50 are very common. So I believe in the number of people contributing to UN Ocean Decade is more than 10,000, it's quite sure. It's a really big data UN Ocean Decade has. And quite big science is ongoing, and a huge amount of money for science have been invested to UN Ocean Decade. And many and different type of result, knowledge, are prepared. Each of them is so precious to reach the goal of each activity project. But I believe in no one can understand everything, the result from the UN Ocean Decade, of course. It is seriously challenging to integrate the knowledge and the data UN Ocean Decade produced and going to produce. And so I encourage data scientists or organizations have potential to develop user-friendly portal to know or to visualize what are ongoing in the decade, and for scientific, for specific issue, to visualize what ongoing in decade, and for collecting data or knowledge for specific issues such as women education and sustainable coastal village, or global warming and fisheries management, and etc., everything. It's not easy and need more effort and funding to support for how to use such a precious data obtained. We need some effort to integrate data. Now we are 2025, and at the later phase of UN Ocean Decade, having science-based decision-making, science-based solution are essential, of course. But I believe full use of scientific knowledge is also essential for best decision-making for such a complex issue we are facing. Again, I encourage data scientists or AI engineers and the supporters to develop best portal of the knowledge obtained from UN Decade Ocean Science. Also, I'm not data scientist or AI engineer. I'm very happy to contribute to this activity if I have opportunity. It may be expensive, but most efficient, cost-efficient, time-efficient way to reach the best decision based on science. Science Policy Nexus will be accelerated with user-friendly portal, database, or platform, integrated knowledge from Ocean Decade, I believe in. Thank you very much.
Thank you, Professor Saito, for underlining the importance of this ocean monitoring, data collections, and application of the data for the proper and effective decision-making and the policy implementations. I now turn to Dr. Takehisa Yamakita, the senior researcher of Institute of Global Change under the JAMSTEC, Japan Agency Marine Earth Science and Technologies. He has been doing the ocean monitoring, particularly marine biodiversity, and I appreciate your input on this subject. Dr. Yamakita, please take a floor.
Yes, thank you, Kobayashi-san, and thank you for giving this chance for me. So today's my title is a little bit longer, and I put several stuff together. But today I will first talk about the deep sea survey and the coastal survey, and about the integration with the environmental or biodiversity observation around the Japan and the Asian regions. And because today we would like to talk about the policy stuff, so I also would like to connect such kinds of field survey and how we can apply to the policy considering the future scenario or evaluation or TNFD, which is the environmental biodiversity disclosure from the private sector side. So at first, key component of our deep sea research activities is like observing biodiversity like this. So this is AUV, what we used for the actually a company. We asked a company to use this AUV to evaluate the deep sea marine protected area newly developed by the Ministry of Environment. And we also doing additional research about the monitoring of the environmental DNA or long-term monitoring in New Caledonia together with IFRAME. And also we evaluating the ecologically, biologically significant area, which is important marine area to contribute international evaluation of the MPAs. However, we also do about the coastal researches in collaboration with Asian countries. And we serve as the secretariat of the Asia-Pacific Marine Biodiversity Observation Network, MBON. You may know heard about MBON or GeoBON, which is a part of the international biodiversity observation network. And we do about the secretariat of the Asia-Pacific version. And we try to evaluate about, essential ocean variables, especially biodiversity part of the essential ocean variables. And we extracting the coverage of the seagrass using field survey and remote sensing using deep learning. And for example, in the case of the Japan, we monitoring changes of the seagrass all over the Japan. Actually, it's only 1, 2, 3, 4, 5, 6, 7 locations for the seagrass. However, we already detected a decline of the seagrass in shallow waters, or increasing the impact of typhoon, or impact of the herbivore fish or turtles. And we evaluating such kinds of the impact by predicting the future condition of the herbivore fish. We also assessing not only biodiversity itself, but also about the benefit to the people. So as you can see this slide, Japan has long history of the use of the marine resources, and we evaluating these several different types of the ecosystem services. And we actually used Ocean Health Index, which originally developed by the Ben Halpan from UC Santa Barbara. And we modified that one for the Japanese coast version. And using such kinds of the indicators, we also, in the right side of this slide, we also evaluating the Japanese version of the shared socioeconomic pathways, which is developed by the IPCC, and we producing the biodiversity version of such kinds of scenarios. And under the different types of the scenarios, we try to evaluate what kinds of the ecosystem services will change in the future. And this work contributing to the IP-based scenario workshop. And at the final, I'd like to mention TNFD is recently really active, and I personally involved in the Tohoku University's activity with a Nature Positive hub, and we are trying to connect such kind of biodiversity observation to evaluation methods and offset or credit or research design to contribute the private sector's evaluation and try to research funding from the private sectors for that purposes. So that's all for our connection from the field survey to future scenarios and private sector's contribution. Thank you.
Very much, Dr. Yamakita, for mentioning this marine biodiversity. Anemone is one of the very leading nationwide research networks on this marine biodiversities and its relation with marine environment changes. TNFD is another key topic, and we see how the nature positive actions can be promoted in the coastal and marine ecosystems. And this is another topic that we certainly want to pursue in this ocean policy discourse. Let me now turn to Dr. Daisuke Hasegawa, Senior Scientist of the Fishery Research Institute under the Japan Fishery Research and Education Agency. May I invite Dr. Hasegawa to take a floor.
Okay. Thanks for your introduction. Please start the slide, please. Yeah, I'm a physical oceanographer of FRA. Today I'll talk about our coastal monitoring and its future vision. Japanese government, Fisheries Agency, FRA, and Prefectural Fisheries Institute have been monitoring Japanese coast since 1950s. And this map indicates the current periodic monitoring lines by fisheries institutes. We deploy CTD, which is an instrument for measuring temperature and salinity profiles of the ocean. And temperature and salinity profiles are utilized for improving our operational ocean circulation model. In the Tohoku Pacific coast, there are 18 monitoring lines in total. The near-shore line indicated by blue are monitored monthly. The offshore magenta lines are monitored a few times a year. The red line is by FRA, line called the A line. We monitor the line 5 times a year. And we deploy CTD to deeper than 3,000 meters and collect water samples for nutrients and phytoplankton. We do also net samples for zooplankton monitoring as well. And nowadays, there are some challenges of ship-based survey. First off, high cost and labor shortages. And as you know, fuel prices keep on increasing. The research vessels, our research vessels are getting old, and it takes a lot of money for maintaining. And the survey budget is also decreasing, unfortunately. And data coverage limitations, because limited ship time, which is also related with the cost, the spatial temporal resolution of the monitoring is limited. Those two figures shows the information. Weather dependence is also an issue, especially in the winter. These maps examples of the area coverage of the observation in January 2022 and May 2023. So obviously in the winter time, because of the rough weather, we don't have much data in the winter. And for improving spatial temporal resolution of our monitoring, we're now utilizing the underwater gliders, which is a robot. So underwater glider can dive down to 1,000 meters while measuring the environment and by the attached sensors, and ascend to the surface, then communicate with the shore through the satellite. 2 branches of FRA conduct glider mission. One is in Shiogama, facing to the Pacific coast, where I belong to. We have 5 French-made gliders. And the Niigata branch, there are 3 US-made gliders. And depending on the mission objectives, We can swap the science bay, for example, for the zooplankton monitoring, we attach the acoustic fish finder, and other complicated measurement can be also done, such as the vertical turbulent nitrate flux by the combination use of turbulence sensor and nitrate sensors. The future vision. Future vision is clear. We want to maintain the existing monitoring lines, and we should observe more frequently by using autonomous platforms, such as underwater gliders and autonomous surface vehicles called ASVs. The current status of automation, which we haven't done yet, but the equipment-wise, we have 5 gliders, and we need 18 gliders because there are 18 monitoring lines. And we do not have ASVs, but we should have some, since ASV is way faster than AUVs. And operators, there are only 2 operators. One is myself, and the other is my colleague. But we both scientists, but we do not have technicians. The technology is nearly ready. And with clear government targets, funding, staffing, realization is within reach. And it's time to seriously consider how we monitor the ocean in the future. Thank you much.
Thank you very much, Dr. Hasegawa, for your brief introduction of your work on this ocean monitoring, including plankton monitoring and its implications. I see so many leading experts and the audience who I'm sure that would like to make questions and comments. But just before inviting the audience to pose a question, I just wanted to ask Dr. Peter de Menocal to make a brief comment. And I think one of the challenges is really how we can use this scientific knowledge for the proper policy development and the implementations. So this linkages, again, if you can comment on this. And another thing is that the people sometimes find scientific finding very inconvenient. So sometimes the scientific finding contradict with the vested interest of some businesses or stakeholders. How can we really deal with this kind of discrepancy between the scientific findings and policy imperatives or the maybe stakeholders' interests? And the last thing, I think a number of colleagues mentioned this cost of ocean monitoring. I am sure that it's really enormous, and you briefly explained how hard it is to do a fundraising to finance your operation. But how can we really see this cost sharing of this ocean monitoring that may not necessarily bring immediate benefit or profit to someone, but that kind of operation has to be financed one way or the other, and how can we really approach this? And maybe with your brief insight, I would like to open the floor for the audience to pose questions and comments. Peter.
Great, I'll try to keep my comments short. Is this working all right? Check, check. That works all right. Thank you, Masa. I think one of the threads that's common in all of our presentations today is just how rapidly the ocean is changing. In fact, it's changing so fast that ecosystems can't keep up, that the warming is outpacing even the natural system's ability to respond. And at some point in the very near future, that's going to intersect with things that really matter to people. And one could argue that we're already there, but if one projects this into the future, the imperative that we've heard, I think really from everyone here, to have sufficient eyes on the ocean comes with it a very strong economic and national resilience, indeed a national security imperative, to invest in that observing. One of the things that we've had a difficulty with in the ocean, and I'll sort of speak on behalf of all of us as oceanographers, is that it's a tremendously remote, hidden place. That's the majority of this planet. Earth is much better called ocean than it should be called Earth. It's 70% water. And our eyes on that ocean are very few. So to me, the opportunity behind this is to really seize this moment when we're observing not only rapid changes in the ocean, but also how it's actually impacting people. Mas, as you said, and how it's impacting societies that are basically doing subsistence living. How are they being impacted? And then how's that financially impacting a certain prefecture, or how that's impacting national resilience. In the United States, one of the challenges that we're seeing is the increased frequency and the cost of extreme storms. Because as the ocean warms, the energy that feeds strong storms increases as well. So not only does the number of hurricanes and tornadoes increase, but their destructiveness increases and the cost increases as well, because it's also coupled to population. All of that is, a compounding, ascending curve of risk. And for the economists in the room, that sort of crossover of risk and intervention is today. And that's where I think is, we can do a better job of making that case of investing in, or inviting nations to invest in that observing potential. The other thing is that we are in possession of technologies that have the potential to really revolutionize our ability to understand the changing ocean at this global scale. One of the things I didn't show in my talk that we're currently working on is trying to build an ocean internet. So you know how there's Starlink that connects us surface dwellers. Well, you can't use electromagnetic radiation in the ocean because it's conductive. So you have to use sound and light as a way to communicate high bandwidth information across the ocean. One of the things we're working with at the Oceanographic is trying to build the protocols for the kernel of what would be an ocean internet. Because once you can get autonomous eyes on the ocean over time, measuring things that matter to people, such as fisheries or changes in temperature, I can speak to this in a moment. Once you're able to make that connection between the inconvenient truth of a warming ocean and its impact on some species of fish that's the favorite of some prefecture in Japan, that begins to be something that's felt by the community. And I think actually I've even heard it from my Japanese friends here that sushi in this country is not what it used to be for lots of reasons. And I'm seeing lots of nodding heads there. And I mean, I'm not even from here, but I sort of, we have the same problem in the United States. The fisheries are moving northward at 6 kilometers a year. So all of our cod and our haddock and our lobsters are rapidly becoming Canadian. And, and that makes a difference to communities that live from fishing. And so our ability to connect these data to things that matter to people, as I tried to say in my talk, I think the hardest thing that I can't do, but I know can be done, is conveying the knowledge to overcome the social license to operate, basically the ability to convince people that this is an actionable, worthwhile activity. And like probably everyone in this room, I'm just shocked by how hard it is to do that. But yet we persevere in this because we know we're right. And I think that's one of the great things about sharing the stage with everyone here is because this is just 2 nations in the world on stage at the moment, but we're doing our best to try to inform that space because we know how important it is. With regard to the cost, one of the things that oceanographers do very poorly is consider cost, in part because the ocean's a very forbidding place to work. But if we treat this as an opportunity to go to scale, it becomes a different problem. So rather than having bespoke solutions to every problem, there are ways to drive the cost down, but that takes a business proposition to say what's the value of those data for a particular application. And this is a place where it would be another presentation, another talk, but this is one of the things that we're also working on, which is what are the future markets that demand this kind of ocean observing at scale. And imagine that time when they demand it, and it's nowhere to be found because people like us are not doing this work anymore, or we've not risen to the challenge. And that for me is the sort of most exciting prospect, which is, imagine you have eyes on the ocean the way we do on land. What would we know? What would we see? What would be the value of that knowledge? And it's a lot of things that we can't anticipate now. And I think that's yet another thing that we have to do. So I've spoken too long already, but those are my views.
Yeah, thank you. And yes, fish move to find a comfortable habitat, and we cannot stop fish getting relocated somewhere else. And I think the number of challenges we have to deal with. So now, I have a pleasure to open the floor, and I see number of familiar faces, and please do not hesitate to raise hand and give us any feedback or comments or questions. Yes, so maybe we go a couple, first gentleman, and then to be followed by the ladies in the back.
I'm an expert advisor at the Japan Fisheries Resource Conservation Association. And I have a question to Daisuke Hasegawa. And you proposed to take place the underwater glider as a ordinary research observation cruise. But in this case, we need some kind of a species level research. For example, the phytoplankton or zooplankton, because fish eat some kind of a limited species. So in your presentation, you measure the planktons using the acoustics. In this case, we cannot see the species. So I think it is better to couple with a video plankton recorder or like some kind of a new cut-edging technology to incorporate to this underwater glider. Because fish eat the planktons, not the acoustics. So please consider.
Maybe we just take a few and we take second questions.
Hi, good afternoon, everyone. I'm Karuna. I'm from the Big Ocean States Initiative, BOSI. Well, I'm actually from Mauritius, but I'm only transiting I'm only in a short transit in Tokyo, and very happy to be able to catch the event while I'm here over the past couple of days. The Big Ocean States Initiatives is a pan-island initiative to catalyze ocean impact, innovation, and leadership. And similarly to what Dr. Menocal said, how we need to rebrand Earth into ocean, we are doing the rebranding for small island developing states as big ocean states because they are big ocean states or BOS. My question has to do with the role of citizen science when it comes to bridging this interface. A lot of our work is focused on both technological and social science. We are building the world's largest database or network of solutions for the ocean that come from the islands. Because right now they are fragmented and disconnected, especially from funding. And one of the key things we are integrating in our work is citizen science. So we wanted to hear from either of the panelists if there are successful examples of how you've been able to integrate citizen science in building this kind of interface. Thank you.
Then maybe I ask Dr. Hasegawa to respond on this underwater gliding research and whether you can make some distinctions between species, and then we come back to Peter and possibly Dr. Saito about the role of citizen science. So Dr. Hasegawa, please.
Yeah, thank you much for the comment. Actually, we are now, trying to implement the video plankton recorder on the glider with combinational use of acoustics, echograms, so that we can, quantify the volume also as species with, the camera. So thank you much.
I'm sorry, I missed your name again? Karuna. Thank you for your excellent question. It was actually one of the things I was going to sort of comment on earlier. So first of all, congratulations on your initiative. It's, tremendously important, and it was actually one of the most meaningful experiences that happened to me at the United Nations General Assembly Hall in New York when one of the island nation representatives commented in the very back of the room about what was actually happening on their island nation in the midst of all this discussion about climate impacts and larger sectors of the ocean and on land. And it was such a compelling narrative because it was so real, and it was a very real impacted community. And where we found citizen science to be helpful actually involves a question sort of that Masa was asking, which involves trust. Because as scientists make these sort of cold measurements of whatever processes in the ocean, we often don't make that information either available or real for people who might be the users of those data. So one of the things that we did actually at the Oceanographic was working with the fishing community around New England, because we have these sensors that are right off of the ocean, and they provide real-time monitoring of, in this case, these warm core rings that get spun off of our version of the Kuroshiro, which is the Gulf Stream. Those actually diminish fishing when they come, when the waves make their way onto the shelf. And so we found a way to warn the fishing communities, look, you don't need to go out because there's going to be no fish there, because the conditions that don't produce fish have reemerged again. And so we built this community of trust between the scientific community, this sensing network, and then the fishing community, so that they're not spending money on fuel, they can paint their boats, or they can do whatever work they need to do to go fishing again. And it's actually been a really great partnership between us as a scientific organization and this community of people who are doing their work out in the ocean. So I think that to me was a really compelling example. I think it worked not because of any particular brilliance on the Oceanographic's part, but really because of one scientist's ability to earn that trust and to build that sense of community around the importance of data. So this is, the takeaway from me was making those opportunities, linking the stuff we do as scientists to the men and women who are at the front lines.
Okay, thank you, Dr. Saito.
Yeah, thank you very much. Very good question. That citizen science is very, very useful for scientific findings. And there are many, many successful examples in UN Ocean Decade and others. In Australia, game fisher or scuba diver take picture of the very new fish species, and they found this supports how fast tropical species migrate to south in case of Australia. In Japan, Anemone is a biodiversity project, ask student scientists to collect water, and this is very good, covering the Japanese course to find out biodiversity. In Woods Hole, campus chemical oceanographer, ask student scientists, pay some money, and send some bucket or plastic bottles and collect seawater in the coast of Oregon or California. And by the money supported by scientists, he measured radioactivity and explained how safe or what is the level of radio contamination. And this is very important for decision making of how it is safe for open swimming area or something. There are many, many examples in UN Ocean Decade. So yeah, it is quite sure this is important for scientific finding. The other important point is if student scientists contribute something, they think this ocean is ours. Okay, this is ocean is not just a government controlled fisherman's stuff or something. But the student scientists think, oh, this ocean is our ocean and should keep sustainable in my kids or offsprings, next generations. This is very important activity for ocean sustainability, I think. And yeah, please check out what is student science ongoing in UN Ocean Decade. Yeah, thank you very much.
And the Anemone is also a kind of participatory network. Yamaki-san, do you have anything to add?
I also involved the Anemone, and as I showed in the Monitoring 1000, it's the national survey by the Ministry of Environment. However, in coral reef and tidal flood and terrestrial work, there is a lot of citizens. However, in in seagrass and algal bed, it's hard to involve citizens because we have to dive. So that, depending on the accessibility, there is a possibility and still a problem to do that.
Thank you. I hope it was helpful. Maybe one, yeah, okay, so maybe it can be a last one, but.
Good afternoon, Mr. Dr. Menocal. Welcome to Japan, and thank you very much for the exciting the presentation. My name is Nagaoka. I'm from the Exodus, this Scottish offshore engineering the consultant firm. I believe in order to maintain the sustainability of the monitoring of whatever the activity, public-private partnership will be the realistic way to go. And I'm wondering what will be the policy direction for the blue carbon the initiatives. We are trying to, in Japan, we're trying to extend the offshore wind farm area from territorial water to deeper, the exclusive economic zone. Then it will be quite challenging to cooperate with the fishermen. So developers are thinking about trying to give the opportunity for like blue carbon or some other method. But we also heard that there are rising concern for the deep marine ecosystem impact after the sink of the seaweed, floating seaweed. So if you have any idea about like the direction of the policymakers' discussion for exclusive economic zone or the deep water exploration. Thank you.
Maybe I can just share one example. So I was talking with one startup company that's working in marine carbon dioxide removal. I won't name them, but I was talking with their team, and they were collaborating with a southern hemisphere country that was looking into using its EEZ, its exclusive economic zone, as a way to capture carbon to meet their Paris commitments. And because the price of removal carbon is so much higher than the trading price of carbon. Trading price of carbon might be $100 a ton. The carbon removal credit of a proven working approach is worth 5 times that or even 8 times that. So one's ability to meet your national individual commitments can involve these kinds of interventions. The challenge is that if you're pursuing those interventions without knowing whether they work or without knowing whether it's durable, whether it's impacting really everything else in the ecosystem, you're causing more harm than good. And I think that's really where, there's an opportunity to use the capital markets to explore this. And this is actually something that we've been looking at the Woods Hole Oceanographic. I can talk about it more maybe offline, but because the scale of the carbon removal market is measured in trillions of dollars per year of a market that isn't realized, it raises the eyebrows of people who are saying, is this the next thing we should be doing as a company? And that's what scares me more than anything, is that if we start treating the ocean, and these things never really end well when that intentionality is brought to the problem. So for me, it's really, this first journey that we're on right now is to really explore what are interventions that make sense. And in some cases, they make a world of sense, like intentional mangrove planting in some regions. It makes it more climate resilient. You actually get carbon credits for it. But getting it to scale is another problem. But maybe I'll just stop there. Thank you.
Thank you for your very informative response. If we had a colleagues, he might have also spoken about this J-Blue credit. Japan also has this system to provide incentives for the seagrass and the seaweed restorations and farming. But again, we also look at this marine diversity values in addition to the carbons. And I think we will continue this dialogue as well. I think come to the time to wrap up our panel discussion. I'm sure that you might have had a little more questions or comments, but please feel free to approach him. He may have to leave soon, but let's give a big round of applause to Dr. Peter de Menocal and for the colleagues who also spoke at this panel discussion. And thank you indeed for your attendance.